Okay, ma'am.
Right? So definitely this question will be there for your CT exam as well as university exam. So be prepared for your diagram itself. The mark will be there. Remember, x-axis pH, y-axis reduction potential. What we have to explain in the Pourbaix diagram, at what pH conditions, at what reduction potential the metal will be protected. Okay, where the corrosion is happened, how we protect the metal, right? So simplify your diagram means the simplified diagram. Look at here. Okay, this is a approximately simplified diagram. This is this one, cathodic protection. Cathodic protection. And here anodic passivation. Anodic passivation. Anodic passivation is there, and here this is a corrosion zone. Corrosion zone, which means this corrosion is there, and here passivation, and here protection. Okay, protection. The metal will be protected in the cathodic region and also anodic passivation. If you increase the pH and or else the negative reduction potential, the metal will protect. Okay, and here the corrosion zone. So here we have to explain what happened AB and ED. Similarly, you have to explain the slow balls. Okay, right? So what is the horizontal line says? One by one we can go. May I move this? Already explained there. Okay. What is the horizontal line says? Yeah. Horizontal line, it explains it separates the electron transfer. See, look at here, from Fe to convert it into Fe2 plus, and Fe2 plus to become Fe3 plus, or else Fe3 plus to become Fe2 plus, Fe2 plus to become Fe. So electron transfer reaction. The horizontal line explains the electron transfer reaction. Okay, electron transfer reaction. Okay, electron transfer reaction. And what is a vertical line explained? This one, TF and CB. What is a vertical line explained? That is a proton transfer. Okay, proton transfer. The vertical line explains proton transfer. And what is a slope? This slope, this one, G and F, D and C. That slope explains both electron transfer as well as proton transfer. Okay. Horizontal line explains the electron transfer. Vertical line proton transfer, and the slope both proton as well as electron transfer. Okay, proton as well as electron transfer. Right? So we have to explain one by one. So horizontal line, that's what I told here. The electron transfer, reduction and oxidation is happening. Okay? Reduction and oxidation is happening. So overall, what is the lines of the diagram? The Pourbaix diagram given there. Very good explanation. When the metal will be protected. If the metal corrosion is happening, how we protect the metal? Iron metal. It increase the pH or else it reduce the potential. Okay. How we protect the metal? That information we get it from the Pourbaix diagram. Okay. So different zones and lines explained, and it calculated the equilibrium states by the Nernst equation. By the Nernst equation. You know that Nernst equation, E equal to E naught minus 0.0591 divided by N into ln Ca. This is a molar concentration, this is a number of electrons, this is a standard reduction potential value. Okay, standard reduction potential value. So first what happened here? The Pourbaix diagram helps us to determine the corrosion behavior of metal in water. Okay, in the water. So normally the Pourbaix diagram, we can make the Pourbaix diagram in the low concentration of metal ion. Okay, we can always in the laboratory scale means we can take a low concentration only. That's the diagram in the lab scale. So when we do the lab scale means lower concentration only. So first what happened, the solid ion zone. Okay, first we explain solid ion zone. Here the solid ion zone, that you know the solid ion zone, that is below ABJ. You can give the name also. What is that yellow color dashed line? That is a water line. Okay, so that is a water line. Normally the theoretical written of stability of water. Okay, the dashed line says above this dashed line water is oxidized. That's why we can take this one is O2 by H2O, and here H2O by H2. Okay, H2O by H2. The above the line oxygen environment, and below the dashed line hydrogen environment, H2. Okay, that we will explain how the H plus H2O is converted into H plus, and similarly H2O how it form a O2. Okay, so that's why here formation of only the oxide. Okay, oxide, only the oxide, and below the dashed line H2. Okay, H2 condition. First, what happened? The solid zone here, the solid zone. That's why here the solid zone, that is below A, B, J. That is humidity zone. Humidity zone. There is no corrosion here. Okay, here there is no corrosion because less reduction potential value, almost negative reduction, high negative reduction potential. There is no corrosion, electron transfer not happened, so no corrosion occurs in this zone. That's why we can say that is a humidity zone, safer zone. The iron metal is a safer zone in the cathodic protection area. This is a cathodic protection. Okay, cathodic protection, no corrosion zone, where the solid iron zone below ABJ, this one below ABJ, here the iron present in the iron itself, it won't convert into Fe to Fe2 plus or 3 plus. Okay, and the next Fe2 plus zone, Fe2 plus zone, Fe2 plus zone, it means here, this one, A, B, C, D, E, here, Fe2 plus zone. So here what happened? The iron converted into iron 2 plus, the electron transfer reaction. Okay, electron transfer reaction, that is a corrosion zone. You write it A, B, C, D, E, or else this is a corrosion zone. Okay, corrosion zone. Here the iron will be definitely corrode. Okay, metallic iron oxidize. Here that means Fe2 becomes Fe2 plus 2 electron. Okay, iron converted into iron 2 plus, it oxidizes. Okay, the metallic ion oxidize to form a ferrous bar. Okay. Now தெரியுதா சிம்பிளா இருக்கா? இதுவா? CA concentration of solution. Yeah, write it. Next Fe2 O3 zone. Okay, Fe2 O3 zone, that means here that is a passivation zone. Okay, passivation zone. So yesterday itself we explained passivation zone, that means the iron metal will be corrode, but the corroded product is deposited on the surface of that metal, it protects further corrosion. It protects further corrosion, that is passivation zone. Okay, so here the metal somehow protect. Okay, passivation zone, because of the corroded product deposited on the surface of that metal, so it restricts the corrosion further. Okay, or else the rate of the corrosion here less, that is passivation zone. Okay, passivation zone, you write that explanation. The iron will be corroded in this zone, but however the corroded product, the corroded oxide film deposited on the surface of the metal. Okay, surface of the metal. I have to repeat, or else I have to dictate. You need this paper. Just note down. Because okay, once I finish, I circulate this paper. This is for just notes only, not for the. Okay, I will circulate later. Once I finish, I circulate this notes for you. Okay. This is an important question because definitely they ask the question either university exam or else CT2 exam or else both. Okay. Next, this is a passivation zone, the Fe2O3 zone, and the next Fe3O4 zone. Fe3O4 zone. Okay. This is also passivation zone only because here also the passivation zone, you know the Fe3O4, Fe2O3 dot FeO. Again, FeO is deposited on the surface of metal, so it restricts the corrosion. Therefore, this is also passivation zone. Okay, passivation zone. And the next, this is the horizontal line. You take a horizontal line. Okay, horizontal line, that is AB and ED. Am I right? AB and ED. AB, yes, AB and ED. Right? AB and ED, it represents what? That is a oxidation. Metal oxidates continuously. So this is it represents the redox reaction. Redox reaction. Okay, here the Fe2 becomes Fe2 plus, as well as the Fe2 plus to convert again Fe3 plus. The number of electron transfer and all you write it, that is no issue. That is a horizontal line, AB and ED there. Okay, that is a independent of pH. That's why we say the horizontal line represent the electron transfer, vertical line say the proton transfer, the slope explain electron as well as the proton transfer. Okay, proton transfer. The AB and ED explain the electron transfer. So electron transfer means it independent of pH. When you change the pH or increasing or decreasing, it won't help. Only depend on the independent of pH. Only the reduction potential vary. Okay. And the next vertical line. You take a vertical line. Okay. The vertical line, it represents this is the redox reaction, but this one is a non-redox reaction. Non-redox reaction. For example, non-redox reaction or else acid-base reaction. Acid-base reaction. That means the H plus ion interaction is there or else OH minus ion interaction is there. Both are involved from the water molecules. Okay, water molecules. Therefore, what happens here? The Fe3 plus, it reacts with 3O2 minus to form a Fe3O4. Okay, Fe3O4. Again, Fe2 plus, it reacts with OH minus. The presence of OH minus means the ferrous hydroxide, FeOH twice. Okay, FeOH twice. FeOH twice, which depend on the pH. So this one, the vertical line, it depend on the pH. The vertical line, what is a vertical line here? Look at from the diagram. What is a vertical line? That is from this zone to that zone. It reacts in presence of oxygen or else OH minus to convert the iron 3 plus into Fe3O3, whatever it is. The oxygen content it reacts with the iron molecules. It depends on the moles of oxygen. How much moles of oxygen it reacts with the iron, based on that the product will be there. And the next, the diagonal line. Diagonal line, that is represent the redox reaction which depend on the pH. That is also is an acid base reaction only. So for example 2Fe 2 plus, it reacts with the water molecule H2O to form the Fe2O3 plus 6H plus ion plus 2 electron. Okay. Or else the Fe, it reacts with OH minus to form ferrous hydroxide, FeOH twice. Okay, plus 2 electron. Maybe here 6H, so that's why 3H2O. 6H2, 3H2O. Okay, that is a diagonal line. Here also acid base reaction only. So acid base reaction means it depends on the pH. It does not depend on the reduction potential. Okay, it is not depend on the reduction potential. So here the above the line, above the dashed line, what happened? So at finally you write it that this diagram. Overall, this diagram, that is cathodic protection, anodic passivation, anodic protection and corrosion zone. When the metal is there here, you have to move either cathodic side or else more pH side. That information we get it from the Pourbaix diagram. Okay, so here the corrosion zone, it indicates you have to increase the pH, otherwise you have to move the high negative potential side. High negative potential side. Okay, so that diagram very clearly explained. From this dashed line says the water line. This dashed line, above the water line, that is oxygen content is more. Below this water line, hydrogen H2 content is more. This means the H2O here. Here, what happened? The H2O to form O2 plus 4H plus 4 electron. 4 electron. This is 2H2O, right? And here, this dashed line, below this dashed line says 2H plus 2 electron to form H2. That's why here oxygen is more and here hydrogen is more. That's why when the oxygen is more, it forms a product of oxide product. Here hydrogen is more, that's why the hydroxide product. Okay, hydroxide product. I'm moving randomly now. So this question is confirmed in your CT2 exam.